Alright, hello guys. So today we're going to be coding and explaining a Sudoku solver. So basically, what it's supposed to do is you input it a board of Sudoku, and then it will solve it for you. And right now I have an example right here. The black digits are the digits that are from the input, and the red digits are the represent what the computer fills in for you. So as you can see right here, each row has different numbers. Each column and each row has different numbers, and also each square has different numbers. So that's what defines a solved solution. All right. So let me erase these. All right, and let's move on to the solution. The solution to this problem is to try all of the possible answers and see which one works. What I mean here is not doing a permutation on these 81 squares, because that would be way too slow, but to do backtracking to solve it. Backtracking is kind of the idea of trying a solution at a given spot and seeing if it works. If it does, you take the solution that it already built and go try the next case. If it doesn't, then you would try another solution. So to do this, we're going to keep track of a visited square. By square, I mean these 9-cell matrices right here. And then we need a visited square, a row, and a column. So row and columns are trivial. You just use the I and J indices. But squares, we'll get to that in a second. So you recurse through all of the possibilities in each cell from 1 to 9. And then if it works, keep it and go to the next one. If it doesn't, try another number. At the end, there will always be a solution. As I said, because we're using backtracking here, the program will be able to solve any board that you input. There's no constraints. You can even give it a empty board. It will still solve it because it is using the concept of backtracking. Okay, so let's look at how to keep track of the visited numbers. So right here I have an empty board with squares labeled from 0 to 8. So here, to keep track of the row and column, basically just add the row and column indices respectively. To keep track of the square cells, you want to use the formula that's the row index divided by 3 multiplied by 3 plus the column index divided by 3. And some of you may wonder, isn't this thing right here just row index? But no, because this is integer division, and what happens is that it truncates the decimal places and leaves us with a whole integer instead of a decimal or a fraction. So here, let me give an example. The row indices right here are 0, 1, and 2, 3, 4, 5, 6, 7, 8. And then let's just use column 0, 1, 2, 3, 4, column 4. So I want to find the square with row index 4 and column index 4. And because this is integer division, after row index gets divided by 3, that's actually 1. So you want 1 times 3 plus 1, which gets you square 4, just as it should. That's how that's how you can keep track of the squares. Right here I have an example. For this problem, I'm gonna use a list of sets. An array of sets would also work, but I'm just gonna use a list of sets for now. As you can see, it's a list of sets. Each index in the list represents another row. So in that list, you can see that this is one row, this is another row, and it's going to continue and continue for 7 other rows. Okay, so this is the basic idea of how to code a Sudoku solver, and now I will head over to IntelliJ and write the solution. All right, so right here I have a class called Sudoku solver, and it has a board as its instance variable. This constructor will pass in a 2D int array for this board, and this is the main body where we solve the Sudoku. And this is just a get board function to print the board after we call it. Right here I have a runner class. This is empty for now, but it will be filling in an array later for testing. And I'm gonna solve it, and then I'll get the board and print it. So let's get into the code. All right now I'll just go define using some global variables, I guess. You want a list of sets. I'll call row list. Actually, I forgot to import. So you need 3 of those because one of them is row, and then one of them are column, and then the last one is squares. This is the last one. And instead of a set, you could also use an array to represent visited cells, but for simplicity's sake, a set is enough. And a set contains function is also O1, so time complexity wise, basically the same as arrays, but if you switch those to arrays, it could potentially be faster. All right, so here we're going to have to pre-fill the list of sets with the values already given to us. What I mean are these values, like the pre-filled board that the user gave. To do this, first you need to go through each and every one of those lists and instantiate the set in it. So I'm just going to use 9 because there are only going to be 9 rows, columns, or squares. Now you need to add a hash set into every one of the lists. And the last one is for square. Alright, so now that I've instantiated the sets in the list, I need to go fill the sets in the list. So that's just 9 as usual. That's another 9. Okay, so here, if board at int j is equal to 0, which means I'm going to use 0 to indicate that the cell is empty. And if it's 0, you can continue. If it's not 0, then you need to first find the square. That's only for the square set. I'll just call it sqix. This will be equal to I divided by 3 multiplied by 3 plus j divided by 3. So that's what it'll be equal to. Then you want to go into list and get the set at that position and add the value onto the set. Right now it's pretty straightforward. You do that for the row and the column, but for row you actually just use I because that's what that's the index for the row. And you want to add these numbers in, and for the column you're gonna use J. Add board I and then J. Okay, this is how you pre-fill the set and the board. And now we can start writing the main code, which is backtracking and recursion. All right. Right now, just to start, if so the solve will take in two two parameters. One of the parameter is obviously the row index. I'll call that Y. Yeah. And the other one is X. All right. So what we need to do now is if Y is already equal to 9, which is at the bottom, we can return true for this because we don't need it anymore. Which means I'll actually change this to a Boolean. So it'll return out of the function if Y is equal to 9. Then we're going to have to calculate the new indexes for the board. So I'll call it new X and then new Y. I'll say what X is first. X is going to be equal to X plus 1 mod 9. That's very obvious because that's the column index, and you want it to mod 9 every time it goes up over. So that's what it does. If that gets to 9, then it'll mod with 9 and go back to 0. Now it's time for the new Y, and that will actually be equal to, will only increase if this X is equal to 0, or it won't increase at all, or it'll just stay at Y. Okay, so I hope this makes sense so far. What we need to do next is check if the board at Y and X is a 0 or a non-zero. If it's a 0, it means it's empty. If it's not a 0, it means we continue on to the next square. So if it isn't equal to, well, if it isn't equal to 0, then we want it to go on to the next square. So return solve Sudoku ny and then nx. And it'll only get here if board at y, x is equal to 0. And that's what we needed to do. Now I'm just going to recalculate the square sqix. But this time the I as seen here is actually the y and the j is the x. So it's y divided by 3 multiplied by 3 plus x divided by 3. Basically same formula, both different variable names. Okay, now is the fun part. At every cell of the board, you will need to go through all of the numbers 1 through 9. So I'll make it smaller than 10 and start at 1. So this loop loops through all the possible numbers from 1 to 9. And if the sets at the given row, column, or square contains the number, then we don't want it. So if row at I contains the number I, then I don't want, sorry, row at Y contains the number I, then I do not want it. If column at X contains the number I also don't want it. If square at square index it contains I, then I would also not want it. So that results in a continue statement for that condition. And if it isn't true, oh wait, actually, yeah. All right, if it isn't true, then you want to add these values to the list to prepare it for the next recursive statement, which goes to the next cell. So you wanted to add it to this set, or add it to the row as well. Oops. There you go. Also want to add it to the column. Okay. Now what the last step you need to do before you can recall the function is that you need to fill the board with the value that you gave it. So now the board will be equal, the board at Y and at X is equal to I. Now you can call the solve Sudoku function and pass in the new Y and the new X that we made here. Alright, so next, this is a crucial part of backtracking. Because some solutions may fail and some solutions may succeed, you now need to return these sets, these lists of sets and this int array to its previous position, or previous state of condition. And what we're going to do here, oh wait, I forgot something here. So because I made this a Boolean on purpose, so when we're solving Sudoku, if this turns out to be true, then there's no point to keep recursing through the solutions. So if that's true, then we're done. We're gonna exit the recursive statement. And you need this to be here is because that if you don't exit here, then it will backtrack all, it will return all of these to its previous state, which means that your board will be the board of your input, and that's not good. So if this turns out to be true, then we're done. We're just gonna exit. If it still needs some work, then we need to do backtracking. So basically, return these values to its previous state. Pretty obvious. I'm just going to copy and paste these here, but instead of add, it's a remove. And once it reaches the end of the function, you can just make it return false. It means it didn't really get anything done. So that is the main body. And right here is the function to print the array. Now let's head over to Sudoku solver runner and see if it works. Right here I have a set of a board, and we're going to put it in and see if it does the job. Board. I needed to solve at 0 and 0. So let's see if it works. Looks like it solved it. As you can see here, every number is different in each square and in each row and in each column. I'm not seeing any mistakes here. So this turns out that it works. And to prove that the Sudoku solver can solve any board, I am just going to put one number. So everything else gets to turn into 0. And that's a 0. That's a 0. Actually, I'll just do it here in the notepad. Luckily, there's a function called find and replace, but that wouldn't be very helpful. I'll replace 3 with 0, 7 with 0, 6 with 0, 1 with 0, 9 with 0, 5 with 0, and 4 with 0, and 8 with 0. Okay, I think 2 is left. Oh, 2 is 0 as well. Okay, so now everything's empty. I'm just gonna give it one value. Let's make this 5. It's not save, copy. Alright, let's paste it into the input set. Okay, as you can see right now, 5 is the only square without that isn't a 0. Let's run it and then see if it gives us the correct results. Alright, let's see. So this row is good. This row is good. This row is good. These rows are good. These columns are good. And the squares look good as well. And as you can see here, we only have a 5. If we change that to a 0, it will be pretty pointless because it'll be the same thing, just that with probably nothing changed, because 5 isn't enough for the program to modify the change. And as you can see right here, this is a complete Sudoku solver with 1, 2, 3, 4, 5, 6, 7, 8, 9 by 9 matrix, and it works on any puzzle that you can give. And that's it for how to code a Sudoku solver. If you like this, please like this video and subscribe to my channel. If you want to see more backtracking videos, you can go look at my playlist, or you can go to my channel page to find out more problems in general. Alright, thank you.